Okay. Here I will introduce a bit about our bridging experience with Sanlian, and yes. First, I will go through a little bit about who we are, introduce our DVDeck a little bit, and there are two bridges. The first Liaow Friendship Bridge, and another one is Meklong Extra Dose Bridge in Thailand. We DVDeck actually is quite an old company for more than 150 years from Germany, and the red logo. The red logo over here, DSI, would be the most famous logo, as you may know, as a DVDeck System International, and we rebranded ourselves from in 2020 with the new CI red and blue logos here. And if we look at DVDeck with the number, we have more than 15 decades in business with more than 50 countries. That we have more than 10 sector, many specialists, and with more than 100 current projects right now. And most important of all, we partnered with Sanlian since 2021 in Asia region. Okay, we have four main sectors in our company. First of all is the post-engineering and state cable system, geotechnics and life management, and this is the reason why I'm here, and also the concrete accessories mainly in Europe. Okay. Okay. In our two main target in lifestyle management, we will say that it was the IHM and RIM, which means infrastructure health monitoring, and also the repair, inspection, and maintenance. And these are the most two important things in so-called OMM phase in infrastructures. And today I will mention more. I will emphasize more in IHM system, and worth mention that in the right part here is the robotic access we use for repair inspection. Okay, and for the DVDeck IHM, our sector of this was located in Manchester in UK, and formerly a Dayton Group. We actually acquired or you can say merged the company from about 2 or 3 or 4 years ago, and this is also the reason why we will cooperate with Sanlian, since it's quite far away, so they cannot support us on the installation or sensors, the part or repair on that. So Sanlian help us on that, and the most. And what they help us with is the infrastructure. We call it infrastructure intelligence part. Is we call it II. It's an cloud-based platform with an integrated solution of the sensors. Okay. Okay. On a computer. Oh, it's a room meeting. Oh, it's a work. Okay, these are the two bridges, and the left-hand side is the first Liaow Friendship Bridge at the border of the Thailand and Laos. It's quite a long bridge across the Mekong River, and it's a traditional pre-stressed concrete box girder bridge opened in 1994. And the right-hand side is a new bridge and still under construction right now, and we call it Meklong Extra Dose Bridge, also known as the Talana Bridge in Bangkok. It's crossed the Meklong River. It sounds alike, but actually not the same river with the left one. Okay, I'll go from the first Liaow Friendship Bridge first. This is the total view of the bridge. It's quite a long bridge, and you can see the drawings here and the site map. And there are 6 piers and 5 main span in this bridge. And with the approaches, there will be more than 1 kilogram in total. And in this project, we cooperate with the Chulalongkorn University in Thailand. And these are the details. I'll leave it to you. And these are our project sensor outline. And we installed strain gauge a 19 strain gauge accelerometer, temperature sensor, deflection, settlement gauge, and also displacement gauge and inclinometer, and CCTVs on that. Okay. These are the drawings and the actual data logger box on site. This actually is from Sanlian. They built this system for us. This is our SHM structure from sensors, data loggers, and some hubs, and they will process the data and send it to our II cloud platform. And yes, and when it comes to our II platform, I will introduce this. We can have access to this system with any computer or iPhone or iPad with anything you can serve on the internet. And this is actually the I interface of the first type of friendship. You can see the sensor map here, and all the pages and these icons. The others, and this is the sensor map. In this project, we have the comparatively simple hierarchy with only one level and only sensor basis. So there are only seven pages under that. The first, we will come from 3D accelerometers. There are 4 accelerometers we install on this bridge, and the four representative span on that, and we monitor the natural frequencies of the box girders. So if the natural frequency changes, we will see, we will know that there is something changes. So the further inspection or repair should be applied. And these are the FA335 we apply from San. You can see that over there as well. And this is the photo we actually shot from the site. And this is the data on our platform. We can see this is the data with a 6 week interval, and we can see the natural frequency. The peak here, this is the mode 1, mode 2. The peak is not moving significantly, so we can say the natural frequency is not changing a lot. So maybe the condition of the box girder is not changing. So this is a good sign for us. And for the strain gauge, we use the vibration wire strain. You could also find that sensor over there. And we applied 19 sensors on that, distributed on the bridges. And the sensor is SG1001, and we have the data back every 5 minutes. When we look at this strain sensors data within a week. This is a week, and these are weekends, and these are weekdays. So you can see the more significant waves, bigger waves in the weekdays: Monday, Tuesday, Wednesday, Thursday, Friday. So it's quite clearly that that is because the traffic is more intense on that bridge in the weekdays. Okay. And for the temperature gauge, we applied a temperature gauge, one on the outside of the box girder and 7 inside the box girder. Outside box girder, you can see here. This one we applied it in the pier. The temperature sense we use it would be TP100, and we have 8 of them. This is very interesting picture here. You can see this one with more obvious wave is the outside one, which means the air temperature. And you can see the 7 temperature sensor in the box girder is a little bit delayed and with more stable strand. Hey? Okay, then this is the deflection gauge, also called the settlement gauge. We want to see the foundation, the condition of the foundation, see if the settlement occurs or something like that. We have actually a set of that will consist from 31 deflection gauge from we call the liquid level settlement gauge. It's a sensor like this, it's an LP150. this is a little graph, little diagram of how it works. It has a water tank, and all these 31 liquid level gouges are connected together, and we could see the relative settlement within the gouges. And this is what we saw that this is in a month. This is in a month. Now we can see this data is up and down within 4 millimeters. This is not a very big value for us, which is also a good sign for us. And since this is not a short-term indicator, we would have to see it with more longer intervals. And this is displacement gauge. We placed 8 displacement gauge on that sensor on the between the pier top and the box girder. As you can see here, these are the pier, and then there's a pier top, and there's a little strain sensor LP200 over here. And as you can see here, we can find, please remember there's a DP04 here. This one is the fixed one. The other one between the pier and the box girder, they are sliding device between them, and this one is kind of a monolithic one, so we will see no displacement over here. As you can find here, the blue straight line here belongs to the fixed ones, and you can see from the left hand side they will go to the negative side, and the other will go this way. You could also see very, very clear patterns within a day, repeat and repeat again. It will mainly from the temperature. Yes, and if we put temperature in, we can find that when the temperature goes hotter and colder with the bigger waves, the displacement sensor will see this. We'll see the same trend. Yeah. Sorry. And when it comes to tilt meter, we also apply the 6 tilt meter on every pier, and also the tilt 03. This one is on that fixed pier. We will see something interesting later. And we apply this Midori inclinometer on the pressure, and the installation is also from Sanlian. And we can see the inclinometer data here in the deep green one here, tilt 03. We'll have the comparatively minor tilt in this data. So we are thinking this might be because that one is the fixed one and with more stiffness than that. And we have also applied two cameras at the end of the bridge, and we have the live stream camera, and also we retrieve a photo per hour. And this is the photos recorded on our system, and I would like to share some interesting. We can see rains and sunset and something like that, and also a train passing by. This is the data acquisition system from Sanlian. These are the actual data box they provide to us. And we're going to Macron extra dose bridge, which also called the Tanara bridge. As you can see here, this is the third bridge over here, lying parallelly. And the bridge we're talking about is the yellow one right here. It's an extra dose bridge. It has 2 pylons, about 250 meter in main span and 340 meter in total. And also the yellow cable here is also provided by us. This is our sensor layout. You can see the sensors we applied here: accelerometers, tilt meters, blah blah blah. And I'll introduce to you later in these pages. We applied 8 accelerometers for the cable force to see the cable force, and 1 temperature sensor, weather station, with include wind speed, wind direction, and rain gauge, and also the temperature and the relative humidity. And 2 in kilometer on the pylon top, and also 4 CCTV to see all the deck. This is the drawing and the actual photo from the site. And this is our SHN structure from Sanlian as well. It's quite a little bit like the first data bridge, also sensors, data loggers, blah blah blah. And the sensor will somehow process the data and send it to our AI platform. And let's see. Let me jump that over. Okay, this is our actual view of the AI platform. We can see this. We can see the bridges over here, and the sensor we apply. With a click in, we could see the sensor data and the graph of the map. The hierarchy of this. This is more complicated. With also we have 2 pylon view. It's a pylon section to see the sensors on the pylon. And first accelerometers for cable force. These are the actual photos of that. We applied 8 accelerometers on that to monitor the cable force, and the sensor will retrieve the data every 5 minutes. We applied the FA135. This is a typo here. It's 135, and with the data logger DMS24 to. This is the photo. This is a photo just installed on the cable. We use a fixture to fix that on the cable and to see the cable vibration. And this is the kind of a method statement of how we transfer the accelerometer, the acceleration to the cable force. We will transfer the acceleration through FFT or PSD, power spectral density, and to fetch a natural frequency of that cable, and then through some simple algorithm, we would get the cable force. And then temperature gauge, we apply 2 temperature gauge. One is in the box skirt, and another is integrated in the weather station here. As you can see, this is what we do. We drill a hole and put the temperature gauge in, and another one is here. As you can see here, the air temperature outside is apparently with very big wave, and the sensor inside the box was also a little bit delayed and more smooth. The weather station here, we also have another rain gauge and anemometers on the pylon top, rain gauge on the deck. We apply these 3 things. You can also see there, yeah. It's all, yeah. And we could also have all the data on the platform. We can see the sensor. We can put it together to see if anyone is influencing another one. And this is wind direction and the relative humidity. Yes, here it comes to the strain gauge vibration. Time's up. It's okay. Okay. Let me go very, very quickly. CCTVs, tilt meters, the CCTVs, yes, photos. Yeah, thank you.